Hello everyone, this is Pavithra, Assistant Professor, Department of ECE, SMS College of Engineering. In the last class, we have derived the resonance of RLC circuit in series, right? And before class, we have started the resonance and frequency. Today, we are going to see about the important topic is called frequency response. It is very important. The frequency response is nothing but the at which the resonance occurs. In that frequency, the resonance is going to occur. It is called as a resonance frequency. As I explained you before, the chalk piece, we can have the chalk piece. Normally, the frequency, the chalk piece have a normal frequency, right? So what will happen is, if we give the forces to the chalk pieces, it going to break down. So that is called as a resonance, right? So the frequency at which the resonance occur is called as a resonance frequency. We can denote it as a FR. Okay, we can denote it as a FR. So in this, when this frequency response occurs means, in normally I said no, in that in series RLC circuit. In series RLC circuit, if this inductance is equal to capacitance means this frequency resonance occurs, right? So we have a formula, we have to derive what is the resonance frequency formula, okay? So we know very well it is an omega L is equal to 1 divided by omega C. In the last class itself, why we are using this omega is nothing but the denoting of frequency. So omega C, it should be written in inverse number, okay? So what happened is, I am going to take it this omega L and this omega C is equal to 1. So already I have said this XL is nothing but omega L and the XC is nothing but 1 by omega. We have to represent in this frequency means, so I am going to write it omega R L and is equal to, here I am going to represent 1 divided by omega R C. Okay. So what happened, I am going to take this term to the opposite side. Omega R and here I am going to take it this omega R into L into C is equal to 1. So nothing but I have taken this omega R to the opposite side. What happened, here it becomes omega R square in LC is equal to 1. So what happened, so I need of omega R square. So it's nothing but 1 divided by LC. So how can we, this omega is nothing but 2 pi F, okay, that is okay. So what happened is, this omega R becomes FR squared is equal to 1 divided by root of LC into 2 pi. So how can we derive this? So FR is equal to 1 divided by 2 pi root LC. So that is the formula for the frequency response. Okay, that is the formula for the frequency response. So how do we derive this? XL is equal to XC, where omega L is equal to 1 divided by omega R. We have to represent in the frequency response. So I have written omega L is equal to 1 divided by omega RC. So I have taken the opposite side and this LC is going to come here. So nothing but the omega R is nothing but 2 pi F. I have replaced FR is equal to. So here we can put it as FR. So FR is equal to 1 divided by 2 pi root of LC. This is the formula for the resonance frequency, which is very important. Okay. Now we are going to discuss a two problem on resonance frequency response. A resistor of 50 ohm and inductor of 0.02 Henry and a capacitor of 5 microfarad are connected in series. You know very well, this is called series. Okay, find the resonance frequency and the power factor of the resonance. So this is how we are going to do it. Already what is the given data? Given data is nothing but R is equal to 50. Okay, and then inductance is nothing but L is equal to 0.02 and the capacitance C is equal to 5 microfarad. Okay, this is going to happen. So what is the formula for the resonance frequency? FR is equal to 1 divided by 2 pi root LC. Okay, so we are going to substitute the value 1 divided by 2 into 3.14 root of, what is this L? It is 0.02 and what is the capacitance? Capacitance is 5. We know that the micro is nothing but 10 to the power of minus 6. So we have to substitute this 10 to the power of minus 6 in the top of the value. So yeah, 1 divided by 2 into 3.14 0.02 into 5 into 10 to the power of minus 6. So already I have calculated it. So the final answer for this is, because what we have to do, we have to get the frequency response. So 503.292 Hz. For this series circuit, I got the frequency response as 503.292. I hope you can understand this video. In the next class, we will discuss about this problem, and here we are going to see about the capacitor. Okay, we are going to find out the capacitor. We can see it in the next class. Thank you.